All right, this is a homework help video for our cumulative or comprehensive review number 1, taken from the problems are on page P20. This is actually the chapter 0 section of our textbook. We're simplifying radicals, so I just selected maybe a sampling of a good representative of all the problems that you had to do. So here's number 7. Number 7, we look at the number first, and again, you're always referring, and you probably don't have to make this list, but this is the way you're thinking. You want to start with the number, see if the number, first of all, is in our perfect square root list. I'm just making a list of numbers that have perfect square roots, and you don't have to go too far, but so this is 2 squared, 3, 4, 5, 6, 7, 8, 9, and 10. Well, 98 doesn't show up in that list. So what we're going to do to simplify the square root of 98 is see if we can find a number in the list that divides evenly into 98. And 49 does. So I'm going to use the square root of 49 because I can simplify that. But I'll have to do the square root of 2 over here because these have to multiply together to equal the blue radical. Okay, for variables, the test is, does the root divide into the exponent evenly? Well, 2 doesn't divide into 3 evenly, so I'm going to make x squared here because 2 does divide into 2, and to make it equal to the blue radical, I'll have to put x to the first in the other factor. Y to the sixth is already perfect because 2 does divide into 6 evenly, so I'll put y to the sixth over here to join the other perfects. And so now this perfect radical on the left can be fully simplified. The square root of 49 is 7, the square root of x squared is x, and the square root of y to the sixth is y to the third. And then this other radical, the square root of 2x, will have to stay radical. So that should be your answer for number 7. Number 11, we're using the quotient property, which really says this. You can think of this single radical as 2 different radicals. And we know that eventually we have to make sure we don't have an answer that has a radical in the denominator. Okay, so the way I'm going to approach this is I'm going to simplify these radicals first, and then I'm going to take care of rationalizing the denominator. So let's start with 63, the square root of 63. All right, close. It's not in this list. So the best thing I can do to simplify this is to pick a number from the list that divides evenly into 63, and that number is 9. So I'm going to represent the square root of 63 as the square root of 9 times the square root of 7. And I'm going to do that same line of thinking for the square root of 8. It doesn't have a perfect square root, but I know that 4 does, and I can multiply the square root of 4 times the square root of 2. At least I can simplify this one, which helps simplify the original radical. Okay, so the top then becomes 3 times the square root of 7, and the bottom becomes 2 times the square root of 2. Now to rationalize the denominator, now we're not worried about radicals in the numerator, but in the denominator, to rationalize this, we just look at the radical. You don't need to worry about the whole number. Just take the radical that is in the denominator and multiply by that on the top and the bottom. You can't do something to the bottom of this fraction without doing the same thing to the top. Okay, so in the numerator, I'm going to have 3 times the square root of 14. Just multiply those two radicals together. And in the denominator, I'm going to have 2, so I just brought this 2 down. And then when I multiply these radicals together, it becomes the square root of 4, which is just 2. And so this original 2 is now going to multiply times this result of 2. 2 times 2 is 4. And then if I could simplify the radical more, I would. If I could divide both 3 and 4 by the same number other than 1 to reduce, I would. But as it turns out, that's not possible, so that ends up being the final answer for number 11. Okay, so thinking about our perfect square root list again, and we only went up to 100 in our list before, so that was 10 squared. 11 squared is 121, 12 squared is 144. 288, we don't have to go that far, but 288 does not appear in this list. 13 squared would be 169. But I know that 144 does. So I'm going to represent the square root of 288 as the square root of 144, which has a perfect square root, times the square root of 2, which does not. Okay, 147 does not appear in the list, but the square root number 49 divides evenly into 147. So you'll definitely want to have a calculator for this one. I can use the square root of 49 and that times the square root of 3. Okay, so the square root of 144 is 12. That becomes 12 root 2. And the square root of 49 is 7 root 3. And now we always want to rationalize the denominator. So the radical in the denominator that needs to be removed is the square root of 3. So that's what I'm going to multiply by on the top and the bottom of this fraction. So the top becomes 12 times the square root of 6. And the bottom becomes 7 times 3. Okay, square root of 3 times itself is the square root of 9. But that is 3. So once I finalize what number comes out of this, I need to multiply it by 7. Okay, so here's a case where, now the radical is done. Do not divide a regular number into a radical. But for the numbers 12 and 21, you're just going back to old-fashioned reducing. Is there a number that divides into both? And hopefully you're thinking, well, yeah, 3 does. So I'm going to reduce this 12 over 21 fraction by dividing each one of these by 3. So 12 goes into 3, or 12 divided by 3 is 4, and then 21 divided by 3 is 7. So you do want to be on the lookout for opportunities to maybe cancel or reduce. All right, number 14, same type of problem. I'm going to try to find a perfect square root number that divides into 108. And so you probably are going to take your calculator and start trying these numbers. 108 isn't a perfect square root number, so you're trying, dividing, see which one gives you a perfect, or it goes evenly, no decimal. So you might right off the bat, don't write this down yet, but you might say, well, yeah, I found 4. 4 goes into 108 27 times. So the danger with 4 is that I now have to simplify the square root of 27 because it has a perfect square root number that divides into that. So this is an example of making sure, I just want to give you a heads up, make sure you choose the biggest perfect square root number that divides. There is a number that's bigger than 4 that divides into 108, and that's 36. 36 goes 3 times. Now, if you did what I did before, that's perfectly all right. You would just have to go through that simplifying process twice. Once you did the 4, and then you would have to simplify 27, and the 2 numbers that came out of that would be 2 and 3, and you multiply those together and you would get 6. I just think it's better to go ahead and pick the biggest number right off the top so you don't have to go through that process multiple times. Okay, so the bottom is, if we thought about this as radical factors, and we thought about our perfect group times our non-perfect group, and I usually just set this up as the left radical is perfect. Well, q to the 6th is a perfect square root variable because 2 divides into 6 evenly, but the square root of 2 is not. Okay, so in simplified form, this would be q to the 3rd power, 6 divided by 2, times the square root of 2. And I'll just go ahead, if that's okay, I'll just go ahead and turn this into 6. Okay, I just wanted you to see how we started off with 36 times 3, those two radicals multiplied together, but it eventually comes 6 times the square root of 3. And now to rationalize the denominator, I use the radical, square root of 2, multiplied times the top and the bottom. So the top becomes 6 times the square root of 6. And then the bottom becomes 2. It's the square root of 4. So it's 2q to the third. But again, look at these numbers, 6 and 2, and see if you can reduce and simplify. 6 over 2 is really 3. So this would be the best option. Always simplify or reduce if you can. All right, that's your answer for number 14. And I got 2 more. So these are going to involve conjugates. So the conjugate of 5 minus 2 times the square root of 6 is 5 plus 2 times the square root of 6. All right, and so now we'll do the distributive property. We're just going to take this blue 7 root 3 and distribute it to both of these. So multiply the whole numbers together. 5 times 7 is 35, and then that's times the square root of 3. And we actually have 2 things to multiply together here. The whole number, 7 and 2, and then the radicals, root 3 times root 6. And we'll come back and do some simplifying in just a minute. Now let's take care of the bottom. So remember FOIL, do the F part of FOIL, that would be 25, 5 times 5. The outside would be 5 times 2 is 10, square root of 6. The inside would be minus 10, square root of 6. And then the last would be, it'd be negative 2 times negative 2. So let me just write this over here. We'll do a little scratch work. Negative 2 times 2 is negative 4. And then we're going to multiply that times root 6 times root 6, which is just 6. And put those together, and that becomes the last. So that would be negative 24. Okay, so what will always happen because of conjugates is these will just cancel each other out. And so we put these together on the ends. 25 minus 24 is 1. Okay, so let's work on this numerator because the square root of 18 simplifies. Should be 35. Okay, so before I come down here and show it, let's just break out how we're going to do 14 times the square root of 18. So anything that comes out of the square root of 18 as a regular number is going to multiply times 14. All right, so we could represent the square root of 18 as the square root of 9 times the square root of 2, which is another way of saying 14 times 3 times the square root of 2. And 14 times 3 is 42, square root of 2. All right, so when we simplified this 14 times the square root of 18, the simplified form of that is 14 times the square root of 2. And that's all over 1, but writing denominator 1 isn't necessary. So that is our answer for number 16. And you might be thinking, well, why can't we add these together? Well, we haven't talked about adding or subtracting radicals, but I'll just go ahead and touch on it now. In order to be able to add these literally and combine them together, they have to be the same. So not only does the root have to match, but the numbers under the radicals have to match. So I'll just give you a sample. It's okay to do 4 times the square root of 5 plus 3 times the square root of 5. That just makes 7 times the square root of 5. You just add these two numbers together. But if I have 4 times the square root of 5 plus 3 times the square root of 4, I cannot add these together because the radicands aren't the same. All right, so let's do our last problem, and it'll wrap up this video. So the conjugate of 2 minus the square root of 2 is 2 plus the square root of 2. And now distribute 3 root 5 to both of these. So 3 root 5 times 2 is 6 root 5. And 3 root 5 times root 2 is 3 root 10. So radicals get multiplied together, and you can think of this having a coefficient of, or a factor of 1 in the front. 3 times 1 is 3, and then the two radicals get multiplied together. Okay, now we'll be able to rationalize the denominator. So f, 2 times 2 is 4. The outside would be 2 root 2 plus, because it's positive times positive. The inside would be negative, or minus 2 root 2. And then the last would be this blue root 2 times the red root 2, and it's minus because it's minus times plus, and that would just be 2. So again, this helps us, using a conjugate helps us accomplish getting rid of the radical, because these are going to cancel, and then we just put these two together. 4 minus 2 is 2. Okay, so like I said earlier, you can't add these radicals together unless they're the same. And I can't do any reducing here because, well, first of all, we're adding these two together, so it's not multiplication. So looks like we're done. These radicals do not simplify. If they could, I would go ahead and do that, but there's no way to simplify the radicals. So as it turns out, this is our final answer for number 18. Okay. So I hope that helps, and if you do have questions, feel free to let me know, and I'll see you next time. Actually, I just realized that is not 18, that is number 19. So you probably already realized that, but I just want to make sure you're not confused. That is number 19 on the homework. And by the way, number 20, if you're wondering, it's in your notes. So if you are not sure about how you did that one, you can go back and see how we did it in class. All right, let me know if I can help.